Now let us see one of the important concept from the tree chapter, that is spanning tree. So how do you define the spanning tree is? It is a spanning subgraph. Spanning subgraph is a subgraph which contains same number of vertices as like given graph G. So spanning tree is a spanning subgraph of a connected graph G, which is a tree. So let us understand it by an example. Suppose graph G is drawn like this. This is the graph G which is drawn on 4 vertices and 6 edges. Suppose I'll draw a spanning subgraph of this graph G. Suppose it is T1. So spanning subgraph meaning is it is a subgraph which contains same number of vertices as a given graph G. So given graph G contains 4 vertices. So spanning subgraph also should contain 4 vertices. There is no restriction on number of edges. Suppose I will consider edges A to D, A to B, and A to C in a subgraph. So this becomes my spanning subgraph, and this is also an tree as this T1 spanning subgraph does not contain a circuit, and hence I can say T1 as an spanning tree. Why? Because it is a spanning subgraph and is also a tree. So T1 becomes a spanning tree. I can also have spanning tree like this, A, B, C, D. I can have edges D to C, D to A, and A to B, let us say. So suppose I'll call this as an T2. So T2 is also a spanning subgraph which is a tree. So I can say T2 is a spanning tree. I can also have spanning tree like A, B, C, D. I'll consider edge D to C, B to C, and A to B. So this is also spanning subgraph which is a tree. So I can say T3. Suppose I'll call this graph as T3. So T3 is a spanning subgraph which is a tree, and hence I can say T3 is a spanning tree. So there can be many different spanning tree possible on given graph G. Now suppose I will assign some weights for every edge of the given graph G. 20 here, 10 here, 5 here, 4, 3, and 10. So accordingly I should put the edge cost in its spanning tree. It is 10, this edge having cost 4, this edge 10. In T2, D2C edge is having cost 20, A to D is having cost 10, and A to B is also having 10. In T3, 20, 3, and 10. Now I have assigned some cost, or I can say a weight, for every edge of the graph. There is a new definition based on this: minimum spanning tree. Minimum spanning tree. Now what it is, we'll see. Now on given graph G, I have drawn 3, let us say, spanning trees, and let us say I'll write weight of every spanning tree. So weight of tree T1 is 10 plus 10 plus 20. I should add the weights or cost of every edge in the spanning tree, which gives you a weight of the spanning tree. So weight of spanning tree T1 becomes 40. Sorry, 10 plus 10 plus 4 it is. So the cost becomes 24. Then weight of T2 becomes 10 plus 10 plus 20, that is 40. And weight of T3 becomes 20 plus 10 plus 3, that is 33. Now among these three spanning trees T1, T2 and T3, the minimum weight is 24, and hence a T1 becomes a minimum spanning tree for the given graph G. So I can define minimum spanning tree as spanning tree whose weight is a minimum.